what kind of things we are going to discuss. So first we'll see what are the components present in that system Verilog test bench environment, and later on we are going to see what each component does, what are the responsibilities of each component, and how later we are going to see one code which for like I have coded for example purpose. I have coded one half header. Basically I have created one half header design, and I have created then test bench architecture in system Verilog for half header. So we are going to see that. So I hope you will like my session. So let's start. As you can see, this picture basically it tells the test bench architecture in system Verilog. So I'm going to explain you one by one. You can understand this is the top level your block test bench top. If you'll see here, you have a top level test bench here. So this is basically known as a test bench top, where you will be having your test. This is a kind of class. I'm going to explain you what does basically. So from here, see, you can see this is a test block, and then you have one interface here, and then you are having duty. So as we know, system Verilog is a hardware design language as well as hardware verification language also. So in system Verilog we have this DUT. We are going to verify basically this DUT, and this is the basically test bench part. So from this test bench we are going to send information to the DUT, and DUT will perform some output. According to that output we are going to decide whether this is correct or not, means our design is behaving correct or not. So simply what I am trying to say is, you have a test bench top and you have three main blocks. First one is test, which is responsible for generating that stimulus. Second block we are having this interface, and third block we are having the DUT. So as we all know, DUT comes from the design team. You will get one DUT which you will have to verify. So the connection between the DUT and test bench you do with the help of interface. So here you can see you have this test bench part, test part, and then you have interface, and you have this part DUT. So you are going to provide some stimulus from the test side through interface, and then this interface will be connected to DUT. So whatever input you are going to provide here, it will come through the interface, and then DUT will perform some output, and that output we are going to capture, and then according to that output we are going to check with the expected values. If you will get the expected values, then you will say that your design is going to pass. Otherwise you can say my design is not behaving accordingly. So let's discuss about this test bench part first. What are the components basically? So inside test we have environment. Environment is having these four blocks. One is called generator, second is driver, then we have this monitor, and then we have scoreboard. So you can see here transaction. So transaction is another class which is responsible for generating different kind of input. So why I am showing this diagram to you, just I wanted to explain you what are the components which encapsulate other things. Suppose that you have this top level diagram, top level block basically. So this top level test bench, this encapsulate your test interface and then DUT. Now this test is encapsulating your environment part, and in your environment you are having four classes. One is generator, driver, monitor, scoreboard. This is also a kind of class, you can say transaction class or packet class generally we say. So let's take another diagram which I have created, and I am going to explain you like what are the things and how this test bench flow works. So let's take just see this diagram. Okay, so now generally what happens, there is a one class packet, then we have this generator class, then we have driver class, we have monitor class also, then we have reference model, then we have this scoreboard, and then we have another monitor second. I have given different name. So we have two monitor 1 and monitor 2. Now see, you are having this design and you have this interface part. So what I'm trying to say is, just be focused. I'm trying to say something, try to understand what I'm trying to say here. I have showed you this picture, just try to correlate. This is the interface part and then this is the your duty part, these two parts, and then we have this complete test part. So this is a kind of top level diagram for test, and if you'll try to correlate here, you will see your design is here and then you are having this interface part. So your design and interface both are connected. Apart from these two blocks, whatever components I have written here, those components comes in the test bench part. So test bench part means this those all are the part of this test block. So inside test we have environment, and in environment we can have these kind of components. So these packet, generator, driver, monitor, they all are the part of basically your test. So that these all classes basically test encapsulate. So inside test we have environment, as you can see inside test we have environment, and in environment we are having these kind of components basically. So these packet, generator, driver, monitor, reference model, scoreboard, and this monitor part 2, they all are part of basically your test. Now I hope you understood the difference, what is design, what is interface, and what are the test parts basically. So now try to correlate here. This is a duty, then you have interface, and then you have this test part. This test part is responsible for generating the stimulus. That stimulus will go to the duty through interface, and duty will perform some output, and then we will get some, yes, so we'll get some output. According to that output we will decide whether my design is working perfectly or is there is some issue. So let's take an example and just let's understand how this flow works basically. So generally what happens, you have a one packet class. Suppose that you are having any DUT. So DUT means design under test, whatever design we are going to test. So suppose that I am taking example of half header. So as we all know, we are in half header, we have two input and two outputs. So A and B both are input, and we have sum and carry, basically those are the output parts. So in packet generally what we do, just we declare all the input signals and output signals. Input signals basically we declare with the rand keyword. Why we declare with rand keyword? Because we want to randomize those input signals inside the generator. Here what we are going to discuss is what is the role for every component. So role of, later we'll see how you can code, or we can see like I have created one packet, one half environment for half header, so you can clearly see how you can write packet class and what are the things there you can declare basically. So right now just I am trying to explain you with definition what it does, what it contains. So be focused and try to listen. I hope you will be having a good idea at the end of this presentation or this session, you can say. So I was explaining you what packet contains basically. So packet class, basically this is known as a transaction class also, anything you can say it. There in design, whatever input output signals are there, you can declare all the input signals and output signal in the packet class. Now this generator block comes. So this is also a class basically. So these all things, packet, generator, driver, they all are classes basically. Now in generator what we do is we take this handle of packet class or transaction class and we randomize those input signals in generator class. So basically in generator we do two things. First thing, we randomize the stimulus, whatever stimulus is coming from the packet, and then we put that information into the mailbox. Now I will explain what is this mailbox concept and what is this virtual interface concept. First try to understand what happens whenever packet, you will declare all the your input signals and output signal in the packet class. Now those input signals you are going to randomize into the generator class. Now in generator class, this is the first job. You will randomize your packet class here, or and the second thing, what you will do, whatever things you have randomized, you are going to put that information into the mailbox. Now why we are going to put that mailbox? Because because whatever we are going to generate from here, what we will do, we'll send that information to the driver, and then through the driver we are going to pass that information to the DUT. If you will see this picture, what is happening here, this transaction class, this is a part, nothing, this is a part of packet class, which you can see here. This is the packet class, or you can say this is a transaction class. So what we are doing here is we have declared one packet class, and we are randomizing that packet class inside this generator class. So randomized information we are going to pass to the driver. Now driver, what it will do, it will pass that input signal to the DUT through the interface. Now whatever input you will pass, DUT will perform some calculation, some operation it will do, and it will produce one output. So what you can do is you can capture all the input output things from here, and you can sample basically those information into the monitor. Now monitor will pass that information to the scoreboard. So scoreboard basically it's responsible for the checking logic, where you can write the comparison logic, and you can decide whether your test case is being passed or your design is performing well. So let's try to understand here in this diagram what happens. Basically what I was explaining to you is just try to understand whatever input signal generator is randomizing, that information will come to the driver, and driver will drive this information to the interface. And as we know, interface and DUT both are connected, so whatever signals are there, both are connected, then input signals, basically DUT will get some input signal, according to that DUT will perform some output, and those input output signal you can capture in this monitor, and then you can pass this information to the scoreboard. Now let's come to this diagram and try to understand what happens. So whenever you want to pass some information from class 1 to class 2, then you can use their mailbox or queue. I haven't mentioned here, but queue is also one option you can use. See, this is also class, so here also we want to pass some information from this monitor to this monitor. So I have mentioned here mailbox or queue, you can use both. Again here we have this reference model and scoreboard. Here also you can use one mailbox or queue, anything you can use. And again same here also. So mailbox or queue is also here you can use. Now you will see one more thing, virtual interface. Virtual interface concept I will explain you little bit later. First let's understand how this basically environment works. Now we were there, okay, so we have randomized the information. Now I have to pass this randomized information to the driver. So generator basically needs a mailbox or queue. So here I have declared one mailbox. Whatever things I am going to randomize, I am going to put into the mailbox. I hope till now you are following me. Generator is randomizing the information. After randomization, it is putting that information into the mailbox. Now driver, what it will do, it will take the information from the mailbox. Whatever information you had randomized here, you are putting that information to the mailbox. So driver will get that information from this mailbox. So if you are aware, mailbox is having two methods, put and get. So with the help of put, this generator will put some information into the mailbox, and driver will use get function for getting the information from the mailbox. So now generator is randomizing the information, it's putting the information to the mailbox. So driver is, what it is doing, it is taking that information into driver. So generally that input information we are randomizing, and input information we are passing here to the driver. Now that input information are basically we are driving that information to the interface. I'll show you how interface and DUT are connected. So if you'll go here, you will see this is the test bench top part. So in test bench top part, what will happen, DUT and interface signals, basically they are connected. So as here we are driving those information here, so these things are connected. Now what will happen, generate. Okay, let's go back to the packet. What I told you is, packet is having your input and output signal, everything is there. Whatever design is containing those information, those all inputs and outputs are present into the packet class. Now generally we are randomizing only input, we are not randomizing output. Why? Because we are going to get output. So just normally we are randomizing input, there is no need to randomize output, so we are randomizing only input part. Now you are randomizing input here, but output signals are also there. So completely you are putting that packet into the mailbox, and this is getting that packet here in driver. So in driver, when it will get, along with input, you will be having some output signals also. So all the things you are going to pass to the interface, and then DUT will perform some output. Now interface is having input and output signals of, from here it will get. Now there are two ways basically. You can use two monitor here, or you can use only one monitor here. So first I am trying to explain you how you can use only one monitor, and then you can perform the all the things. So just for time being, remove this part from your mind. Just think you don't have this information, this block, this monitor 2 part, this path is not present here. Just try to understand you are having this path, and you are driving some information through the driver to the DUT, and everything you are capturing here in monitor, and you are passing some information till scoreboard. So for time being, just forget why I am using this monitor 2. I will explain you, don't worry, but for time being just forget it, what it is. Okay, sorry. Okay, let's focus another thing. So I was explaining you got all the input and output signal here. Now DUT will perform some output, it will get some input signal from here. So if suppose that you are having the half header, suppose that you have only one bit signal is there. Say you have input A and B, they are only 1 bit signals, and you have output sum and carry. So when you will give A is equal to 0 and B is equal to 1, then half header will perform something, and then it will produce some output sum, and if conditions are there, then it can produce some carry also. So suppose that you have given some input and it's producing some output, means it's giving some or carry. So everything, whatever input and output things are there, you can capture here, you can sample those information here. Okay, so let's go back and little bit try to understand again. You are passing information, you are randomizing information, and then you are passing that randomized information to the driver is passing that information to the interface is connected to DUT. So if interface will get some input, DUT will also get some input. According to that input, it will produce one output. So all the input and output things you can sample in monitor. How we are going to sample that information, we'll see in the code, and with the help of code I will show you how the things are getting executed. So don't worry about that part. For time being, just understand whatever things you are going to drive here, it will produce, design will produce some output, and those all the things, input and output things, you are going to sample in monitor. Again, now this is your monitor part. Again we have this is a reference model. So monitor is basically, monitors is used for the sampling purpose. You will sample the input output signals in monitor, and there is nothing more to do in monitor class. Now we have this another class, you can say another component. This is a reference model. So reference model, what it does, and what is the responsibility of this class, I am going to explain you. So try to understand how this verification happens. So there are two areas, one is design and one is verification. Where design team is totally different team, verification team is totally different team. So this design under test, whatever design you are going to verify, right now I am verifying this design, that is a half header. Okay, so this design under test DUT you will get from the design team. Okay, so this design you are going to verify. Now this reference model is a model, you can say this is a similar to DUT, but this reference model is written from the verification team. Design is written from the design team, reference model is written from the verification team. We create a logic which is similar to design. Okay, in reference model we are going to create a similar logic to your design, and that logic we are going to write, means verification team is going to write. So we don't have idea how the DUT is written, or you can say there is a top level person under whom one design team is there and one verification team is there. So there is a one specification will go to design team and one specification will come to your verification team. Both the teams are going to write their own logic. Design team's logic is known as DUT, and verification team will create their own logic. According to that, this reference model is created. So this is similar to your DUT only. Now see here, you have input signal here and output signal also, you are sampling both the signals. In the reference model, as I told you, this is similar to DUT. So whenever you will pass that information again, so okay, so how you can pass this information to reference model, you will put whatever things are coming, you will put into the mailbox or queue, and then this reference model will get that information into this reference model block. Now reference model, as I told you, this is similar to DUT, so there will also be a logic which will be performing the same thing like your DUT. Now see, this DUT has given one output, sum and carry. Here in reference model you have another logic which is similar to your DUT, and that is also going to produce one sum and output. Try to understand. DUT will give some output, and in reference model VR means verification team is going to write something. So verification, when this monitor will give input to this model, so that model also will produce one output. Now you will be having two output. One output is from the design team and one output you will get from the reference block. Now what you will do is you will compare this output to your output, and how you will do, basically you will do this part into the scoreboard. So here you write a comparison logic. You will check whatever output this model is performing and whatever output is coming from the DUT, is both the things are equal. If both the things are equal, then we say my test is passing, otherwise we say a test is failing or design is not performing well. I hope you understood what I am trying to say is. So basically we are going to compare this design under test and reference model outputs in the scoreboard. Now sometimes this reference block is written inside the scoreboard. I have written that code where I am not mentioning this reference model. You can write a reference model class also. This is a standard, basically standard environment. So because of that I am showing you. So but I haven't written this part. I have implemented this part inside a scoreboard. So if you don't want to write that in reference model separately, you can write those things inside the scoreboard also. You can write here and you can check whether the output is equal or not. Now see why this second monitor I had taken. So try to understand this. If I am using two monitor, so what happens basically, from here you drive your input signals and output signals. You are driving your input signal here and output signal onto the interface. Interface is connected to your DUT. Now what you can do, you can sample your input signals, only input signal in monitor 1, and whatever output is performing DUT, you can sample that information in monitor 2. why I am doing is because in reference model we need only input. There is a first way which I have explained you, that is also correct. You can sample your input or output signals here also, in this monitor also. But if suppose that you are using two monitors, then what you can do is you can sample your input signals here, and whatever duty is performing, that information you can sample in monitor 2. So you will get one output from here. That output you will pass to the scoreboard through the mailbox. Again, you will put one mailbox here, means whatever information comes you will put in mailbox, and then the scoreboard will take that information. Now whatever input signals you are sampling here, that input information you will give your reference model. Now reference model, as you know, this is there is a logic which is similar to your duty, so it will also produce one output. Now that output you will sample here. Now you are having this designs output, and then you are having your reference models output. Now you are going to compare these both outputs. If both outputs are equal, then you will say this is means your design is behaving correctly. If both the information are wrong or they are not matching, then you will say this design is not functioning well. I hope